Today we're going to look at how to calculate the curvature of the ball Earth using our open source online calculator over at earthcurvature.com. Calculating the curvature is easy using the 8 times distance in miles squared to get the curvature in inches. You can divide the answer by 12 to get the answer in feet. Example for distance 100 miles is 6,666 feet or 2,032 meters. This formula, however, is not easy to use when you're not used to miles, feet, and inches. It's also not 100% accurate over really long distances, as I'll show later. Heading over to earthcurvature.com, we can easily calculate the drop in curvature. You'll see we get 31.4 meters if the distance is 20 kilometers, and it goes up very quickly. There's a table down below for usual distances, and you'll see that when you enter the long distances, that it's very accurate, and if you enter half of the circumference of the Earth, you get the maximum drop in curvature. And if you enter any value higher than that, then it just starts going back to zero. So entering the full circumference of the Earth will actually be zero, which is to be expected. It also works for miles, and if we enter 100 miles, we see that here that we get 6,668.4 feet, which is not the same as the 6,666 feet we got with the 8 times distance in miles squared formula, which is not accurate. So why is this calculation accurate? Moving on to the explanation, we see that we're not using Pythagoras in any way. We're actually using a cosine function. Using the radius of 6,371 kilometers from Wikipedia, we find that the circumference is 40,030 kilometers. We wish to find the height h, which is the drop in curvature over the distance d. Just look in the drawing for the letters. Using the circumference, we find that 1 kilometer has the angle 0.009. This is because the Earth is, of course, 360 degrees. The angle is then 0.009 times the distance d. The derived formula h equals radius times 1 minus cosines to the angle of a is accurate for any distance d. I found this formula by trial and error, and it's 100% accurate for any distance. It's actually a general formula for any kind of ball. Just change the radius and you're good to go. It's also open source. You can click the source code link or right click and go to view page source and scroll down. You'll see the JavaScript code that I made, and you'll see the Earth's radius, and you'll see I'm calculating the circumference using pi. Then I'm doing conversions and calculating. It should work for any unit you may want to use as well. This can be extended in the future to include more options. So you see, we can easily calculate the drop in curvature, and you actually get 31.4 meters drop in curvature on only 20 kilometers. Do you see that in the real world? I don't. Just a quick tip: when you're out in the world, how do you measure the distance that you're viewing so you can use it in the calculator? Go to maps.google.com, right click on your location, you select measure distance, and then you just drag the little ball to wherever you're looking at, and you'll get the result next to your initial location, which is in this case 17 kilometers. Good luck.